Hello students, let us solve a problem from NEET UG Paper 2019. Here is a problem. In this problem it is stated that body A of mass 4m moving with speed u collides with another body B of mass 2m at rest. The collision is head-on and elastic in nature. Then you have to find out the fraction of kinetic energy lost by the colliding body A after the collision. So to solve this problem, let us consider a very general situation of elastic collision. Suppose there are two objects A and B, they are moving with velocities respectively UA and UB, and let us suppose their masses are MA and AMB respectively. After certain instant of time they have a collision, that is elastic collision and head-on collision, as you see, and after the collision again they start moving with different velocities than earlier. And suppose the object A attains a velocity after collision is VA and the velocity of the object B after collision becomes VB. Now in this problem you have to find out the fractional change in the kinetic energy of the object A. So if you can find out the final velocity or the velocity after collision, then we can find out the kinetic energy after collision. We know initial speed UA, therefore we will be able to calculate the initial kinetic energy, and we have to take the difference and divide that difference with the initial kinetic energy. That is called fractional loss of kinetic energy of the object A. So the main agenda will be to find out the velocity of the object A after collision. Now if we apply linear momentum conservation before and after collision and the conservation of kinetic energy for elastic collision before and after the collision, then we will be able to reach this equation, which will provide you the velocity of the object A after the collision. And this velocity you will be able to find out in terms of the initial velocities UA and UB and MA, MB, these are the masses. Similarly, you can find out the velocity of the object B also. What you have to do in this equation, you have to just replace A by B, subscript A by B. Look this form. Anyway, we need only this velocity. Now we can calculate the kinetic energies, but you need to know what are MA and MB and UA and UB, etc. So look, in this problem it is given that MA is equal to 4m, MB is equal to 2m, UA is equal to U, that is the initial speed of the object A, but object B was at rest. Now if we put these values in this equation of VA, then we get VA, or the velocity of the object A after collision will be U by 3. Now we can use this velocity VA to calculate the kinetic energy after collision, and we know before collision the kinetic energies are calculated now, final kinetic energy and initial kinetic energy. Then you can take the difference of those kinetic energies and divide that difference in kinetic energies by the initial kinetic energy. And if you simplify a bit, you will get that delta K by Ki, that is the fractional loss of kinetic energy of the object A after collision, and that is found to be 8 by 9. Therefore, the Second option would be the correct answer for this question.